insights into different approaches to create, structure, build, test, and survive server-side Java projects. We will set up a few Java SE, Quarkus, Jakarta EE, and microprofile projects from scratch and explain the principles with working code and also answer your questions. Our guide through this journey is Adam Bjorn. Adam has been working on Java since the JDK 1.0 days, which is like really, really a long time, and JavaScript since 1995. He is an architect and a hands-on developer and coach. Over the last few years, Adam has helped many clients migrate Java EE, Jakarta EE, and microprofile applications to serverless architectures on AWS and Azure. Adam has written several books on Java FX, J2EE, and Java EE. He is famously the author of Real-World Java EE Patterns, Rethinking Best Practices, and Real-World Java EE Night Hacks, Dissecting the Business Tier. Now, both books I strongly recommend you to pick up. Adam speaks regularly at conferences and organizes live virtual online workshops a few times throughout the year at airhacks.com/airhacks.live. And his YouTube channel is very popular with Java programmers who want to really keep themselves updated with what's happening in the world of Java. So Adam, we're truly privileged to have you join us today, and we can't wait for you to begin. Thank you.
Okay, thank you, Shashi. I hope I pronounce your name correctly. And you shouldn't go home or quit right now. I challenge you. You have to ask questions and challenge me. Maybe you find something where you say, okay, this is still too complicated, and why you're doing this way? I would do it differently. It should be a conversation. Also, all attendees are invited to ask questions at any time. So let's start with the show. Oh, funny fact. I proposed this session months ago, and then Starof Java said, maybe we need a little bit more Java. And then I proposed another title with a little bit more Java. And what happened then, the session was announced with the old title and the new abstract. So now what I will do, I merge the content of two sessions. So you get both. You get, the past, present, and future of serverless Java, plus a bit of best practices and even cloud deployments. I will try to manage to show you everything in 1 hour. It should be fun. Always has to be fun. What I understand, Starof Java is something like a Java user group, and this is always fun. Okay, yeah, I really like Java. That's basically all my projects I do is Java. Currently, everything is Java 17 or higher. So my personal projects are Java 19. My commercial projects are actually all project Java 17. What I have here, my online workshops, which are more or less interesting, so you can download the content. So this is the there is no workshop, I think, about serverless, but there are lots about Java. Then AIX News is just meta list. If you're interested in events, feel free to ask here. I will just I'm just pushing new, updates regarding newest events. What you might like the most maybe is the podcast. So this is like a weekly show where I have freestyle conversations with people from the Java ecosystem. And that's basically it. And yeah, this is the podcast. For instance, we had cloud migration story from J2E to serverless Java, or we had one about AWS Lambda events. So if you're interested in this topic, maybe you will also appreciate the podcast. Now, also interesting for you is also like community thing, which I really actually enjoy. Is this the AirHacks TV monthly show? How this works is, if you have any questions left after this session, you are free to ask your questions here and in a GitHub gist, and I will answer them. What's really interesting, or what I find exciting, is this show has more than 100 episodes. So it runs for 8 years already. So what I did is, or what I do, I review the questions from 100 episodes ago, which is roughly 8 years. And what is funny, most of the questions are still up to date. So this is always fun. Okay. And there are some workshops on the horizon in December. There will be lots about serverless Java. Why I focus on serverless Java right now? It has particular reasons, and I will talk about this during the entire show. Again, feel free to ask questions. Okay, now deployment time machine. So this is how I started. I started with Sun Java Web Server, and the yellow boxes or orange boxes, what they signalize or what they are applications, or what you could do with Java Web Server. There was one server, and you can ship multiple apps to the Sun Java Web Server. And this is the page. Actually, I find the page on Internet Archives. And yeah, it was from 1998, but I started with the server. I think this is the version 2. I started with version 1. It was 1997, and I have wrote one of the first or the first application actually in Europe or Germany, because it was not available, and I waited, until it becomes available and tried as quickly as possible to hack the first servlet. What's interesting, you see here there is CGI, Common Gateway Interface. And CGI is interesting because it's very similar to AWS Lambda, actually. And servlets are also similar to AWS Lambda. I will show you some source code soon. Okay, this was the next stage. We had J2E application servers. So there are different opinions on application servers. Why I really like the application servers is because you got a single API and you didn't have to bother with the implementation. This was actually the huge, from my perspective, it was the huge added value of application servers, that you didn't have to understand persistence power tier, Gemstone, Tidestone, Bolland app server, and web application server. You just got one API and you were productive. So this is why I like them. So what's crazy, orange boxes still share deployments, and this light blue boxes means back then architects still believed that if you separate the web container from EJB container, it will scale better. Somehow back then there was a belief if you distribute the application, it will scale better. And by the way, some people still believe if you do the same with microservices, it's the same impact. So if you have, if you split your microservice applications to multiple microservices, it will scale better. It can, but usually you have exactly know what you are doing. Then it will. So this was the next optimization. There was Java EE application server, only one blue box. So we gave up, to distribute the EJB container and web container. Everything was in one process and still share deployment. Then something interesting happened is we said, okay, there is no more separation between the infrastructure and the business logic. We are optimizing, we are consider the entire thing as an app, and there is no more app server and application. We only get the application. And by the way, all of you have to ask at least one question. So this is actually the job here, right? I'm speaking and answering, and you have to ask questions. Okay. So now, this was like past, because Docker, and what I have to admit, for I think 2 years already, I rarely using Docker, because what happens now is I'm using right now mostly AWS Lambda. 1 year ago, I used mostly Azure Functions. So it really depends on the projects, but right now, mostly AWS Lambda. So what it means is we are not shipping containers anymore. We are shipping zips, which I also would like to show you today. Okay, this was about that. And if you are into open source, there's an interesting project called FN Java. It was announced a few years ago at JavaOne. And this FN Java project is about serverless Java. So you can just download it and try it. And actually, Oracle functions are based, or is a commercial offering of FN Java. So if you like to experiment with events, take a look on FN Java. Okay, now past. And past, I mean prior to Java. It was earlier than 1995. So what is about the architecture? So I would say before Java time, we had consumption-based pricing. Pay for what you use. We were serverless, and we had virtualization on ZOS and containers on Solaris containers or zones. And what I remember is, as we started with Java, and there were lots of host migration projects to Java, the host or the architects always ask me how to have like query-based pricing. So how to know which project consumes how much, resources or costs. And host was able to provide that. So what I remember, I had a chat with host architects, so mainframe architects, and they were able actually. So we were the Java application server team, and we called the host. And what sometimes happened, we got a call from the host people and say, look, this query is way too expensive. You will pay, a lots of course, the money was not paid directly. It was somehow, calculated behind the scenes between the departments. But we get a call if our queries were too expensive, if they cost, too much costs. So this was back then. So I would say back then, it was also serverless kind of, because the host was there. What I forgot actually to write down, I created the slides before the show, thought about this. We had something like cloud IDEs back then, no kidding, because I don't know whether you saw already AS400 development or SAP, they are working in a terminal. So it's not like they have to install something locally. The entire environment is inside a terminal. And I had the possibility to talk with the people back then, with the developers, and they really loved that. They said, this is incredible. This is a way better what you have in Java. They really like that experience. Particularly, I was in a SAP project where we migrated to Java. All the ABAP and SAP developers really like the experience of the IDE in the terminal, the integrated IDE, right? So now, present, I would say what I still see is subscription-based pricing. So it changed from, pay for what you use. You're paying for the Kubernetes cluster all the time. Whether someone uses the cluster or not, no one cares, right? So this is the state of the art, I would say, right now. And the same for databases. So if you install a database in the cloud, you will pay 1,500 euros for database with a backup all the time, regardless whether someone will use it or not. So Kubernetes. Interesting appearance of Kubernetes. So what Kubernetes is actually an open source project initiated by Google, and to make the cloud, I would say, cloud programming model more popular. And of course, because Google is the initiator of Kubernetes, Google has the best GCP. The Google Cloud has the best Kubernetes support, and the best, the best, or the most developer friendly, I would say, implementation of Kubernetes. Then what I still see and is reasonable on premise is Docker Compose. And by the way, we have actually to differentiate whether the architecture is on premise or the architecture is in the cloud. So the Kubernetes is mostly on premise. In the cloud, it makes less sense. So what I see a lot of Kubernetes on premise and works great is OpenShift or Rancher. In the cloud, we see something like ECS Fargate or Azure App Service, Azure Container Services, Azure Container Instances, and Kubernetes is great on Google App Engine. In the Google Cloud. Now, future. I would say the future looks like the past with different tools. What I see a huge interest, especially in the management, is consumption-based pricing. So what it means is, what actually some of my contracts currently are, is invoice optimization. So we get on the invoice, they say, okay, why this is so expensive? We look at the at the invoice and we try to optimize the costs. With Java, you will see in a second why. And pay for what you use means you are paying for invocations, you are paying, and if you are not invoking, you're not paying, and if you're invoking, you're paying. So this is the huge difference to the subscription-based pricing. In the present, where you are paying all the time, regardless whether it is used or not. So shared serverless compute and storage. So pay for what you use. We added serverless compute and storage. So what serverless CPU is, compute is somehow simple. It's, for instance, AWS Lambda. They started with it. Storage is harder because you have to decouple the compute from the storage layer. So the best example is AWS Aurora, for instance, serverless Aurora. So what it is this is more or less, an Postgres or MySQL database with compute detached from the storage, and the storage is handled by AWS, and automatically replicated to multiple zones. What interests us in project, or us, my clients in projects, is so-called shared responsibility model. And what it means is that the clients and the cloud, they are sharing the responsibilities. And because we are paying for the cloud, what interests the architects and managers is that actually the cloud gets more and more responsibilities, and we should pick less and less responsibilities. What it means concretely in Java: instead of creating Docker container with a super image, with an operating system, which we have to pick and patch, and Java has to be installed in the Docker container, which has to be also patched, why not just tell the cloud provider, I would like to have Java 17 or Java 11. And then the cloud provider installs for me Java or manages the Java, and I get the freshest version of Java. I don't have, to think about the patches and security stuff and the how this called non-differentiated heavy lifting. I think this is the common term, right? So, and what I like to have is keep it simple and stupid. So KISS, keep it simple and stupid. This is actually a software engineering term, and this is also back to the roots. This is why I also liked back then J2E. I just focus on the API. Say, okay, the vendors can do whatever they like. I just ignore all the proprietary stuff. I focus on the API. Okay. Any questions from the chat? No questions. Shashi, do you have any questions? Are you still with me? You are muted, maybe. I warned you. You will have to interact with me. So someone from Starof Java have to ask questions. He's muted. Okay. Why Java? Now it comes, right? So you can ask now why I'm not doing, Node.js or Python in the cloud, for instance. And the answer is simple: because Java is quicker, and if it's quicker, we pay less. That's all. So, and how much less? I would say 10-20%. This is the general, measurement. And you can say, yeah, but Java sometimes, it really depends, could consume more memory, and this really depends on the model. For instance, as AWS Lambda, in order to execute faster, you have to buy more CPU. And you can only buy more CPU you only get more CPU by spending or by buying memory, RAM. So what it means is we have far more RAM than we can actually consume. And with Java, we have, if you would like, for instance, to have one CPU, you have to buy 1.7 gigs of RAM. And with 1.7 gigs of RAM, this is more than you can actually consume, right? So this is the interesting part, and with one CPU, Java is incredibly fast and faster than the scripting alternatives, and we saving costs. Productive, if you consider the entire life cycle, and I'll show you in a second, how it looks like. It is productive because you don't there are not a huge amount of dependencies, maybe one or two. We have the Maven. We have everything is integrated. The IDE experience is great. So we have Eclipse, we have NetBeans, we have IntelliJ and Visual Studio Code, which are used today. And established, I would say this established means this is almost boring with Java because there is I don't expect any problems with Java because it's 25 years old and it's battle proof. And perfect for serverless. So I would like to prove the point in a second. So design tips. So now come to the second part. And before this, maybe I would like to show you some code. So maybe means I will. This is my Firefox. And what I forgot to tell you is whatever I show you, I will check it into Airhacks, to the Airhacks project. So the slides are already checked in. So if I reload this, there should be slides. Are they? No, we'll have to push. And this is the project I created actually today to show you the entry point to the cloud. So I will just clone it and hope that it works. And maybe I will clone it to somewhere else. Wait a sec. To our temp folder. better idea, because if I clone it to a repository, it can cause some trouble. Now, what this is an entry point serverless Java application. And I will start with the Java code. This is the HTTP listener. And I just showed you how most of the serverless stuff looks like. And what I get here is on every HTTP request, I get API gateway v2 HTTP event, which has the entire HTTP payload. And then I have to return a node 200. And this is how AWS Lambda started. So this is a synchronous Lambda with HTTP API requests. You see, this is two hours young. So I created a project to show you how Lambda started. So I'm not using such things in production. And in fact, as I saw this the very first time, I said it really reminds me, at CGI or servlets, where we had a huge switch blocks and said, okay, when HTTP method get, do this. When HTTP method post, do this. And this is, we did it, 1997. And then struts happened, where struts did it internally, and we just called the actions. I would say this code is not particularly interesting. What's more interesting is we can also use Java for infrastructure as code, which I use actually all the time. And this is more productive and even simple. So the entire project, it is a main method with project environment and application. So this is some tags. And what I'm doing here, I'm invoking here a function URL stack. A few lines of code on what the stack just says is the function, this is the name of the function. I would like to create a Lambda, my Pojo, and create a function URL. What function URL is not meant to be in production, but is because in production, I would use HTTP API gateway with a nicer domain name. This one is just, for quick hacks, because you get a generic DNS name, which is not really nice. So, and I have a Lambda here. And the Pojo Lambda, I say, okay, I would like to have a half of CPU with 1 gig of RAM. Timeout is 10, no Docker container. I just say, I would like to have Java 11. And this basically it. So this is the entire code. So now, why I'm showing you this? Because this project is actually Maven. And the cool story about Maven is I could create a jar from this and share it somewhere. And if you have multiple teams, the other team can check out my construct. And, in a minute, we are operational. We don't have to deal with YAML. We just say a new serverless project and everything is set up. So this is why infrastructure as code combined with Maven and CDK is actually very interesting. So Shashi, any questions, or chat? Any questions?
Nothing on the chat yet.
And you have
nothing.
to ask question now.
No, I'm following, and if I have any questions, I'll
So why are you not doing this right now, Shashi? Exactly what I'm showing you,
No, I mean, some of this is new to me, so that's the.
Do you see? This is after the show. This is then the future. Then you can take over. So what I will try to do is I didn't try that. I will try to deploy it. And build and deploy. Don't ask. So what happens right now? It will build everything. And yeah, and I will switch to. So what is missing is a small JSON file with the app. So it is not checked in, but don't worry. Don't give up and do it. Do it here. Works better. So what was the problem? As CDK JSON, there's a small file which is missing. I will check it in. So this is the problem. I forgot to check it in. So it will happen after the show. So you get the example. Okay, but so the Lambda is now, is in the process of deploying. So you see the absolute cold start, and we creating now the entire infrastructure from scratch. So what you see here is, from source code, there is nothing in the cloud, to having a function with exposed DNS fully functional with Java. So this is what happens behind the scenes. So I'm open for questions. So now would be perfect time for questions, because I think It will take 30 seconds now until it is fully available. And why it's slow? This is very first time. This is slow because the entire DNS infrastructure has to happen as well. And if it's done, we get, what I can show you is actually what's interesting. There's no magic. So this build script, it just does Maven clean package and deploy. So there is no specific tooling or scripting. It's just Maven clean package and CDK deploy. That's all. And actually CDK deploy would even be sufficient. So this is the don't ask. Why don't ask? Require approval never. So it will just happen without asking me whether it's okay to provision the infrastructure. Okay, in 70 seconds, it is provisioned. So if I go here, now you see the experience of a cold start. So if I go here and say curl and run it, so it will call the Lambda, and this was the cold start of the Lambda. So this is how long it takes. This was the Pojo Lambda, and we get the responses back. So now, if we go to the Cloud Watch logs and take a look at the listener, view log stream, and we have this one. This is the current. You see, these are the headers. Method is get. There is no body. And the execution time is 37 milliseconds, 2 milliseconds, 2 milliseconds, 2 milliseconds, 2 milliseconds, right? So what it means is, wait a second, this is the build duration is now 2 milliseconds because it's always rounded up. So we are billing for 2 milliseconds per invocation, and we would pay for 1 gig of RAM, right? So what it means is, if we go now to calculator AWS and perform a calculation and say, this is wrong. I'm searching for Lambda configure. And in Frankfurt, ARM is fine with Java. Number of requests, let's say 2 requests per second. So it means per second. And the duration, we had 2 milliseconds, right? But more realistic is 100 because I say there is some business logic going on. It's not like hello world. And the amount of memory was 1 gig. 1 gig. So if we take a look at the costs, it will cost roughly 10 euros or something, or $3. Okay, $3 is because there is a free tier. Without the free tier, it will cost a little bit more. I think roughly per second. There was memory was 1 gig. Duration, let's go 100 milliseconds, show calculations, and this costs $8. So for $8, we can write a Java microservice which runs all the time, 2 transactions per second, scales up to 1,000 instances in parallel, because up to 1,000 means it's a default per account. And on Azure is the similar story, or a Google Cloud Function. So there is not a huge difference between cloud providers. It just started with AWS because I'm using AWS in my current project. And also AWS was the first. So AWS started actually with the Lambda. Okay, so and if you would do the same with Kubernetes, you will pay 100 euros just for the Kubernetes plane, control plane, without any worker nodes. So this is the difference. Okay, so you saw now Lambdas on the cloud, but what I showed you right now is not exactly usable, right? So what I don't like here about this is I get here my where is it? I get here, an API gateway v2 HTTP event, and I have to care about the low level, headers and methods. I have to write the parsing and dispatching. No, parsing not, it is already parsed, but I have to react, when get with this parameters, I do this. So the command execution is cumbersome to implement this, right? So what is the alternative? So, and the alternative, show in a second. So just close that and go to another project. And both projects are already checked in my GitHub account. And I'll call it Starof. And now I show you something which is actually more productive and a little bit more interesting even. So good news first, it is exactly the same actually setup. So from the cloud perspective, so I'm using here a function URL, but the Lambda looks different. So from the cloud perspective, no difference. From Java perspective, huge difference. What I can actually ship here is entire micro profile of Java EE application. And what happens here, I have a JAX-RS, so greeting resource with path application, and you see this is micro profile of Java EE. So we have dependency injection. So I injected here the greeter with some config property and greetings. And this is a Lambda. So we are misusing Lambda as a runtime. And we could run this without, caring about HTTP, just JAX-RS what we do for 20 years already, and save costs with Lambda. So, and behind the scenes, Quarkus is working for us. And the cool story is what we have here. This is actually the entire magic. What happens here, the Quarkus understands the HTTP API gateway events, and it invokes behind the scenes for us very efficiently the JAX-RS layer. So I don't have to care about, about the HTTP and all the stuff. So now what I can do is I'm in the Lambda. I can say Maven compile Quarkus dev. So, and what will happen is the Quarkus started as a Lambda. And watch this. If I go here and open with curl localhost 8080/hello, I get back hello Quarkus on AWS. So I'm actually talking to local application server, if you will, and it works. So now I kill this. And by the way, it didn't want it to be killed. But if I change to Quarkus for Starof, and do it again, you see Quarkus for Starof. So so it reacts to my changes. I can very conveniently, develop I can conveniently, without any difference to local deployment, deploy or handle my Lambda. Now, if I do this Maven package, what happens now is that here in the target folder, there is a function.zip. So what means is, what happened behind the scenes is the Quarkus packaged the application as Lambda. So there is no executable jar, it's just the Lambda. So what means is, if I just do the same, now, before I do the same, I would like just to make it, wait a sec. Any questions in the chat? If not, Shashi will have to ask a question, of course. This is the job here of the moderator in the panel to ask questions. Shashi, a question. Let's do Starof. I'm expecting a question from you.
Okay, yeah. No, one of the things that I've been thinking about is, we've seen some of this thing with respect to cold start speeds, right? So, so if you have, we're talking about something like an AWS Lambda, and there's, let's say, an API, does that create a problem?
Yeah. So with Quarkus, if the application grows larger, usually you will see startup times roughly as cold startup in 2 seconds. But what you can do, you can buy provisioned concurrency. Then for $15 a month, the Lambda will be never cold. So that this will completely eliminate the cold starts. And the cool story is, with the provisioned concurrency, the individual requests are a little bit cheaper. So if your Lambda is used a lot, maybe even you can save money with provisioned concurrency. But you're right. if your Lambda is used not that frequently, and I did some measurements in Frankfurt, every 700 seconds, I think 700 seconds, the Lambda becomes cold. So if your application is called, very rarely, that's the problem. And what I actually plan to do is to ship Lambda right now, and you will see what is the cold start of an entire microprofile or Jakarta E application with dependency injection, microprofile config, and so forth, and JAX-RS stack. So the entire JAX-RS stack is there. Right. Are you happy?
Yes.
Very good, Shashi. Shame on the chat. They should ask at least one question, even in chat. Can they write to me? Or...
Yes, they can. Yeah.
Okay, then say at least hello, chat. Or are the lost host and panelist? Or are you very shy? No. Okay, this deploys now the entire Quarkus application to the cloud as AWS Lambda. So it means for application developers, there is no difference right now between microservice code and the Lambda code, or between application servers and the Lambda. And this is where I spend most of my time currently, is to help my clients to migrate such projects to such environments. And I think this will take like 60 seconds or 19 seconds. So Shashi, any follow-up questions?
Okay, so no, yeah, so because we used to receiving response times that are typically like 300 milliseconds, 400 milliseconds. So, but yeah, the provision concurrency thing makes sense. It doesn't set you back by much.
No. And this is like the synchronous HTTP API gateway Lambda. What you usually will do, you can write asynchronous Lambdas in Java. And what's also, okay, now it was deployed. You see 73 seconds was the entire deployment of entire Quarkus to the cloud. Right. So if I now watch this, let's do time curl this with, I think is hello, is the, so, and now you're experiencing the entire cold start. And so this takes, how, 3 seconds was, right? I think it was 3 seconds. And now watch this. Subsequent calls are 100 milliseconds, the entire round trip, 100 seconds. And the cool story is it gets faster and faster because we are not using GraalVM, we're using the stock Java virtual machine, and the entire stack gets optimized, the bytecode gets optimized, so we get near no, I would say, machine code speed, right? So, and if we take a look at the console, so there's a CloudWatch, and just go here. No, this is now Starof. This is different Lambda. And take a look here. You will see that this was the Quarkus startup time, and the initial duration. So the cold start was 2 seconds. From my point of view, were 3 seconds, and all subsequent calls were 7 milliseconds. And as you can see, the Java virtual machine consumes completely 150 megs, but I have spare 850 megs because I bought one CPU or half a CPU. I'm running on a half a CPU with 1 gig of RAM. In my production environments, I'm working usually with 1.8 gigs of RAM or 2 gigs of RAM to get 1 CPU. This is a half a CPU, and so this is actually good news because you can pick your existing code, write old code, and package as a Lambda. And we have project with several hundred classes in a Lambda, and it works well. So you don't have to have a single purpose Lambda. You can have as many Lambdas as many classes as you like, and you are not limited to one endpoint. You can have as many endpoints as you like. So it means as many HTTP paths as you like. Okay. Shashi, happy?
Perfect. Yes.
So what are the design tips? So as you can see, what I meant here, the build tools, whatever, I'm just using what's there. And most of companies have the tools already, and we can just reuse the tools and go to the cloud. So that's the idea. Design tips, what I suggest in my project is no dependencies. So all dependencies are not allowed except you have really good reasons to use them. No nice to have design patterns. So, as you mentioned at the beginning, I don't know, a few years ago, I even wrote a book about design patterns, but my point was use the design patterns only if you have to. I think, if you exaggerate with the design patterns, you cause more harms actually than advantages. So, just, write simple code with what I showed you right now. There's not even need for Java interfaces. Forget about factories. Just inject classes and write simple code, and then you will save. If you write simple code, it will also execute faster. And if this code is simple, it's easier to test, and the chances for security problems are lower. Use the platform. It's a huge thing. So if I'm on Java, I tend to use Java SE, APIs or capabilities first. So I would prefer to use Java HTTP client before I use, the Jakarta Commons HTTP clients or whatever, because it's there. The same is true for microprofile. So if I'm starting with microprofile, I would just use, the microprofile HTTP client before I use a different client. So this is the philosophy which works well. So for years, I sometimes I say, okay, but maybe the dependencies are nice in Java, but after the problems with security, everyone believes now that, or everyone, the common sense is, if you can just restrict the external dependencies. And with the microprofile, what I showed you right now, Lambda, we are actually only depending on microprofile. There's no external dependencies there. So know your enemy. Your enemy is the time, I would say, the time or the duration. And what's important in my eyes is to think, what's your enemy. So what it means is, if you're on premise, for the long time in Java development, we actually wanted to be vendor neutral. So the enemy was, the vendor. So what it means is we wanted to be independent from Oracle, DB2, Postgres. We say, okay, JDBC, we write JDBC, then came Hibernate, to be independent. Then we introduced JPA, not to be depending on Hibernate. And this was, our battle, to be independent from the vendors. And actually it worked well, because if you do this, you can really switch projects from one server to another. So now in the cloud, your enemy is complexity. So if you're going to the cloud, what you are expecting is that you get something. You are buying services in the cloud. So you're already spending money. So, and you would like, to have something out of that. So I would say in the cloud, if I'm investing in the cloud, I'm not trying to decouple from the cloud. So, use the platform means if I'm on AWS, I look first on AWS services, because before I pick something different. If I go to Azure, I just pick whatever Azure provides me, and I use something different. So what it means is, I showed you the Java code. It was actually CDK, Cloud Development Kit in Java. So because I was on AWS. On Azure, I will pick Bicep. This is another language for provisioning, but not, invent my own language or write my own scripts. So use the platform, help us to save time. And in the cloud, I would say the complexity or the time is actually the enemy, or is always the time is the enemy. And what interests me in the cloud is, okay, let's say I'm implementing an ECS Fargate application on AWS with Java, and now management decides to move to Azure. What interests me is it possible? If yes, how complex it is? And long story short, very easy. So actually, if you take a look at the Fargate configuration and the Azure App Service configuration, or ACI, they are very similar. So it takes actually no time, because in both cases, you have to specify the Docker image path, you have to specify the CPU, the RAM, and whatever. What's more complex is the entire security groups, networking, but you cannot abstract from it. So I would say most of the companies are afraid of wrong things in the cloud. So I would say the enemy is not now the vendors in the cloud. The enemy is complexity. So this is why I don't even try to abstract from the relational database in the cloud. If I use Aurora and Postgres, I use Aurora and Postgres. And therefore, in my eyes, Kubernetes in the cloud is less interesting, because on AWS, you get, easier services to use. You will you will save time by deploying to Fargate, or on Azure, you will save time by deploying to Azure Container Instances or Azure App Service. So domain first means focus on business and then technology, and measure then optimize. So I wouldn't optimize. Actually, I'm performing right now a code review. And there's lots of code which is highly optimized, but the optimization increases the complexity. And if you measure it, actually, it executes slower than it should because no one measured that. Okay, now architecture tips. So I would say keep it simple and stupid, and you aren't gonna need it. So delete whatever you can. Don't distribute. So to my eyes, write large monoliths which are well structured but simple. So large but simple, well structured and simple monolith. This is my advice. Don't create 500 microservices and then think about how to coordinate or orchestrate them. If there is no need for microservices, we don't use microservices. And right now we are misusing Lambda as host for monolith. We could write, single purpose Lambdas, but why? They are more complex to handle, more complex to deploy. If there is no problem, no distribution. Distributed transactions, XA, don't even start with it. So it is not a good idea. So asynchronous invocations for asynchronous use cases means if we have no use cases which are asynchronous, so we can also do the entire flow asynchronous. But I don't like to provide asynchronous endpoints for synchronous use cases, because this is really the beginning of the end. Reactive programming for reactive use cases. So what means this? If I have HTTP API which is not reactive, I would just get with request response. But if I have a Kafka API or Kinesis or SNS or SQS, then reactive programming makes sense. Why? Because I'm reacting to events, so which is reactive. HTTP is not reactive, so there is no reactive programming for HTTP. So what I do, and it works like great. I'm starting with nice monolith. This is what happens. So how to navigate a project, right? So I would say use standards. First, use boring technology. Start with the least common denominator, LCD. So what is the least common denominator in JVM? Is Java. So I get lots of questions. Why are you not using, Kotlin? I say, okay, because 2 years ago, I will ask why I'm not using Scala. And now Scala almost disappeared and Java still remains. So I'm developing just with Java 17, really happy with it. I don't think that Kotlin, Scala, Clojure, Groovy, Jython, what else? I don't know, will actually increase my productivity or experience. Java 17 is great. Java 19 is even better, and Java 20 is going to be stellar, I guess, because we get Project Loom and structured concurrency on Java level. Also very important, make explainable choices. So if there is an architectural decision, it should be absolutely obvious why we're doing this, right? So I reviewed I think last year, a project, and no kidding, I think they had like 5 different languages and 5 different Docker super images. And I asked why, and there was no reason. So everyone used whatever she or he wanted. So we had, in this project, there was Kotlin, TypeScript, Node.js, Java, Micronaut Java, Quarkus Java, and Postgres Java. And I asked them why, and there was no reason. So that it was hugely complex. This was polyglot programming, and but it was a mess. And right now, they agreed on Quarkus, and everything is Quarkus. Everything is way simpler. Now let's talk about the ultimate internal structure. And Shashi, your job is to ask questions, right? So if you say, okay, now, and if you don't ask any questions, my expectation is after the show, you delete your all Node.js projects and switch to Java, of course, right? So this is, you have two possibilities. Either ask questions or huge migration after the show. So this is now.
No, I would choose questions over migration.
Yeah, exactly. So this is boundary. And I will ask the Starof Java community, whether you migrated everything to Java. So I will meet again. So boundary control entity. So why this is the oldest pattern I could find. This is ancient. The icons are shown in a second, and the basic idea, maybe I show the idea on the next slide. We have a boundary. These are the icons, by the way, control an entity, and I use this approach to structure applications, as backend applications as well as front-end apps. So we use the same structure for web components and JavaScript. By the way, Shashi, if you like, we can do a show with web components in one point of time. Not this year, later, but what it means is the entire API layer is in boundary. Control is reusable logic, and the entity is the data. So, and we have multiple components, which are Java packages with business names, and every package has the same structure, boundary, control, entity. So that's the idea. So what I did, I tried to find a project which I can share with you, and I found maybe the oldest one. I used that in one of the first books. It's called X-Ray, which is on the X-Ray was like the it actually is. It provides statistic for my blog. And so if you open the project, you see those are the packages. These are the components: configuration, exports, hits, imports, logging, statistics, and versioning. So if I take a look at configuration, I say, okay, boundary control means there's no data. So if I go to configuration, you see this is 11 years old, the project. And interesting, if you take a look at the in the imports, it is exactly the same API as my AWS Lambda, which is the newest stuff, right? And which help us save money. So this is actually a great migration story. 3 years ago, I touched the code the last time as I migrated to microprofile. So, and now this can be actually completely deleted because microprofile config just provides configuration. Back then, 11 years ago, there was no configuration, so I wrote this by myself. So this is what you had to do, but this was basically all. But the control, no, there's not even control, it's just configurations, a simple code. So exports is just export resource. Then I have hits, which hits resource is JAX-RS endpoint again. I have most popular post fetcher. I don't know what even is. I didn't look at the code for 3 years, and I wrote it 11 years ago, actually. And the control, you see, this is daily hit cache, which has some business logic. Yeah, I even used Java 8 back then, which is remarkable. So this is provided. Now I will use var, but back then there was no var. Yeah, and if you take a look, so this is the same structure. So the point is, also, I didn't look at the code for 3 years, and I wrote it 11 years ago. The structure is always the same, and I know exactly in imports, I expect something with import, right? So there's an import functionality, there's logging functionality, so there is statistics functionality. So if the stats don't work in my block, I will look at the statistic and say, okay, something is wrong, maybe in the exactly daily hits calculator, which was written 9 years ago. And the daily hits calculator, there's some scheduled actions. Oh, I migrated this Quarkus, seems like. And, or? Yes, Quarkus. And every once a day, this is calculated. And I see the code right now, by the way. It's time to migrate it to Java 17. So I can delete some code, and I could even ship it as Lambda if I like now. And this is actually the beauty of Java. So you can write simple code, 11 years ago, and it will still viable. And this is actually a huge success story where actually my clients, bigger companies, really like, because they don't have to reinvent the wheel every 2 years. They stick with Java, and for years it remains compatible. For developers, of course, is what it means is you have more free time because you don't have to learn all the time. You can just stick in a project, but it's more boring. So if you enjoy vacations and you like, to enjoy your life, maybe Java is the right choice. Okay, this was like a walkthrough for boundary control entity pattern, and this is one of the oldest projects, but I can show you there's no NDA, so this is why I opened that. And the interesting part, this is even, there is a system tests layer, which invokes the application from outside. Right now, it seems like I used a JAX-RS client back then. Right now, I would rather use microprofile REST client. So instead of doing this, we are injecting interfaces, but it's exactly the same code. And this is, how old is this? 3 years old. Okay. So this was boundary control entity live. So these were the packages, and every package had boundary control entity. And you could name them differently. The point is, boundary control entity is documented in several books. If I name them differently, I would have to justify in all projects. I'm a consultant, actually, to say, okay, I call it service and not boundary. And they ask, okay, service maybe is cool, but why not to call it endpoint? So, and then we will have to initiate a meeting just to talk now about a name. Okay, so what it means is keep your code simple and stupid. Use hotspot. The JIT is great. It optimizes all the time. You get the fastest performance. If your performance is fast, you will save money in the cloud. You will make management happy. You can save costs with Java. So there is no reason to move out. Actually, I get a lot to do. This is why I reschedule the meeting all the time because of my project. So my problem is time. And if people recognize how actually efficient Java can be, they're interested in running in the cloud. So optional micro profile in Jakarta E. What you saw, you don't have to use a micro profile or Quarkus. The first Lambda was actually without Quarkus, was just Java SE, is perfectly fine. But if you would like to implement an API or a REST service, I would say something like Quarkus or Micronaut are a better choice. Now, the serverless impact, what it means is, so you cannot rely in serverless world on shared singleton. This is the huge difference to Java in a container, because if you have multiple transactions which are running at the same time, there are multiple processes, not threads. So you cannot share a static field. So this is the problem. There is no connection pooling. If you think about this, we cannot just open 50 connections per Lambda to a Postgres. If we have 1,000 Lambdas, we get 50,000 connections. They should be stateless. They can have state, but the state has to be the same to all clients. I wouldn't cache anything in the Lambda. And we use actually application scope for everything for optimization purposes. So what is the main difference to back then? So in containers, there was one app server with multiple threads. And in Lambda, we have multiple processes. So they are executed multiple processes in parallel. So what it means is, on Fargate, if you create a Fargate applications, you get 4 CPUs in a Docker container, and all these threads running on 4 CPUs. In Lambda, if we have 4 requests, we have 4 CPUs, 1,000 requests, 1,000 CPUs. Or in my case, 1,000 requests, 500 CPUs, because I gave my Lambda a half a CPU. Okay, on-premise or in the cloud, if you take a look on this, this is a different strategy. And we are a little bit out of time. So on-premise versus on cloud means on-premise, still the strategy decoupled from the vendors. In the cloud, I would say keep it simple, because the entire point to go to the cloud is to save costs and to use the cloud and not to decouple from the cloud. So if you go to the cloud, you use as much cloud as possible, that your responsibility as small as possible. That's the point. Okay, so you saw the code, so live, so this just on the slide. And these were the projects I used. This was the function URL CDK, Quarkus Lambda CDK, and X-Ray. Everything is on my GitHub account. If you're interested, you can just take a look on this. And if you're interested, there's this was like Hello World Java. If you're more interested in true architectures, there's an online workshop, so should work even from India. And actually not should. There were lots of Indian developers in my workshops. It was actually lots of fun. And the first one is about event-driven architectures with serverless Java, and the next one, I will just talk a little bit more about persistence for serverless Java and how to deal with persistent things. And that's all. So now I'm open for questions. We are actually on time, so 1 minute earlier, which is unusual for me. So questions.
Yeah. So first of all, thanks a lot, Adam. Brilliant session. I've learned quite a bit from it today. Some questions got sent to me, so I have compiled a few. Just wanted to start off with one question that I have here with respect to there's this long-standing debate between using Lambda versus EC2, and the general thinking is that if your system has stable, predictable demand, go with EC2. If not, go with Lambda. So when we're trying to implement a serverless application where it's neither here nor there, what would your default choice be?
Yeah. So EC2, you will save money first, because EC2 is the cheapest solution. If you pick EC2 and S3, for instance, it is the cheapest possible combination you can get if you have predictable workload and it runs all the time. I would say in most enterprise workloads, it is not the case. So then, if you consider EC2, one EC2 machine is not the answer. So you will need 2 EC2 machines. If you have 2 EC2 machines, you need 2 EC2 machines in two VPCs, and then because you will at least would like to run them in two availability zones, and then you need the application load balancer, which balances the load between the two EC2 machines. And to make it more secure, what will happen is you will get a public and private VPCs with NAT gateways between, and the NAT gateways will cost you money. The IP addresses for the EC2 machines will cost you money. VPC and the load balancer cost you money as well. So you have to pay for it. And the next thing is, which operating system runs actually on the EC2 machine? So in today, world, we will have to patch the operating system continuously. We have to patch Java and provide all the patches. And then the question is, we have to test rolling update strategy with the application load balancer. It is there. It's called code deploy. So we could actually do this. The problem is you need developers and you have time to implement this. With Lambda, everything happens behind the scenes. So in 70 seconds today, I deployed an application which is more stable. This is what I described you right now. So I would say if you have one EC2 machine, for Minecraft, go for it. But if there's an enterprise application, I would say an EC2 machine is not the answer. And even I would go a step further. If you're migrating from on-premise to the cloud, for instance, something like Nginx could be used or as a web server, or HTTP or Apache. As a web server in the cloud, I wouldn't use a Docker container at all. I will use, for instance, S3 as a web server because it's serverless. So I would say, by the way, great question. But how I see this is, in the cloud, I would have to deal with the infrastructure as little as possible, because the cloud provider is always better than me providing, the patching, security, and scalability and robustness.
Got it. Perfect. So, and then, one more question. So you made a very interesting point about microservices and the over enthusiastic move towards microservices, regardless of whether microservices are required on a project or not. But yeah, on the other side, well-structured, long functions, does that have an impact on performance when we're using it with Lambda?
Not at all. Actually, I wrote an article on AWS about that, and it was accepted, which is remarkable, because I will try to find it. It is AWS blog, Adam Bean, Coreto, Lambda. Maybe I will find it. Yeah, here it is. Is this year? And what I described exactly this, right? Fed functions, and it was reviewed. The review took at AWS several months, but it walked through because there were no arguments against that actually. So or there were arguments that the article is too complex, we should split it. So this was actually the feedback. But what you have to think about is Lambda is used in Python for machine learning. So they added to Lambda, I think right now it supports 6 CPUs and up to, I think, 10 gigs of RAM or more. So if you think about this, Lambda is more powerful than Fargate because you get 6 CPUs and 10 gigs of RAM per request for a single execution, not for multiple threads, for one thread. So what I can tell you right now, what I showed you the approach, we use this for several hundred classes. So our application is quite complex and there is no performance impact with Java. Because the cool story is Java bytecode is small. If you don't have any dependencies, the Quarkus runtime is tiny. So it starts really fast. And Java doesn't care whether we have 500 classes or one, and Quarkus optimizes. What Quarkus performs behind the scenes is tree shaking. So even if code is not used, it's not even started. So to my observation, there is no impact, there's no relation between the size of a Lambda and performance. And what you should also know is I'm not using GraalVM as Lambda, but because there is no need. With GraalVM, I will save memory. But if I use just Coreto, which is the stock JVM on AWS, every invocation, this Coreto optimizes the bytecode a little bit until the Lambda becomes cold again, right? But if I call my Lambda frequently, it gets optimized all the time.
Got it. Perfect. We'll go through the article and also share this with the participants here on the chat. But otherwise, fantastic session, Adam. Sincere thanks from all of us here. And we would really love to bring you back for another session on JavaScript, and preferably
Or we can do
next year.
follow up from this as you
Yes.
like, next
Yes.
year. So we can do this.
Absolutely, yes. And thanks a lot for taking the time and doing this with us today.
And this was 2 sessions in one. So
Right.
actually, I sent you 2 abstracts. You agreed to both for 1 hour. So I merged 2. The first part was the first, and this was unique session. So I created the slides before the show.
Right. I know it came through really well, and thanks a lot for doing this today.
Thank you. See you next time.
Yeah. Bye-bye.